So now I'm going to show you how you put the experiment together to measure the specific heat of water. So I have here, I have another one just like it. So I have a little aluminium cup and an aluminium stirrer that will fit inside this quite well insulated cup. Now, if you don't have something like that, then you can always make use of a polystyrene cup, though it would be good if you could get some flat sheet of polystyrene to act as a lid and insulate the whole container. So I've already measured the mass of water that I've got in this cup, and in fact I've also measured the mass of the aluminium cup and stirrer. So I'll put those masses in the sheet that goes with this, so that maybe if you want to, your students can actually work through, because I'm going to include the mass of the cup and stirrer and the specific heat of aluminium in my calculation. But if you're just using the polystyrene, then you just look at the water on its own. So now I've got this circuit. I've got a power supply with about 6 volts. Looking at the circuit, I'm now going power supply to a switch that's currently open, switch to an ammeter that is set to go up to 10 amps, ammeter to my heating coil that I've made sure is submerged, and then heating coil back to the power supply. And I'm using a data logger with a temperature probe, so that's in there too. I have to make sure it's not touching the sides. I'm trying to keep it suspended in the water, so I'll do my best to do that, especially while I'm stirring it. If you don't have something like that, you might just want to have a lid for your cup that actually has a hole that a thermometer can stick through and stay submerged in the water. If you've done that, you'll still need to keep stirring the water, because this only really works if the water stays pretty uniform in temperature. So it might be worth actually getting a bit of wire bent into a circle with a stick, having a small extra hole in your lid so that your stirrer can go up and down like that and keep stirring even with the lid on. So let's just start this going now. I can see I have an initial temperature of my water of 22.8 degrees, and I'll start the data logger running. And now I'm also going to add in my voltmeter to this simple circuit, and I will close the switch, and I can see that my current is reading 1.79 amps, and at the moment the voltage across my coil is 4.93 volts. So while the water's heating, students can be calculating the power level that's going into this water. And I just have the little stirrer here without bumping against the probe too much. I just try to stir the water, and I can tell from the shape of the graph how successful I am in actually keeping the water temperature pretty uniform. So the idea is that you stir it for about 5 minutes. Try to heat it as uniformly as possible, because what we will want is the gradient of temperature over time for that interval. If you've got the data logger and the graphing software, then you can look, find a nice, fairly uniform rising part of the graph and get that gradient. If you don't have that though, if you're just using a thermometer, then you would be able to just measure the temperature every 30 seconds. And look, at worst, you simply have the initial temperature, the final temperature, and you record how long you heated it for. There's nothing wrong with that, and in fact it might be worth doing it that way in order to keep your cup better insulated. Right, so after 5 minutes of diligent stirring, I've got a graph that looks like this. You can see obviously a bit of fluctuation in there, but in that 5 minutes the temperature went from 22.8 degrees and it finished at 31.6. And if I want to look at the gradient of my slope and do it that way, then I'll take a selection and I'll pick my gradient button, and this says that the gradient is 0.0152 degrees centigrade every second.